So the next element is astatine. Astatine is the 85th element on the periodic table. Elements are arranged in the periodic table on the basis of atomic number. Astatine has an atomic number of 85. It is located in the group 17, period 6, and block P of the periodic table of elements. It is denoted by the symbol 80. The name comes from the Greek word astatos, which means unstable. In 1939, two groups came near to discovering this element in mineral samples. Horia Huluve and Yvette Cois analyzed mineral samples using a high-resolution X-ray apparatus and thought they had detected it. Meanwhile, Walter Minder observed the radioactivity of radium and said it appeared to have another element present. He undertook chemical tests which suggested it was like iodine. Element 85 was convincingly produced for the first time at University of California in 1940 by Dale R. Corson, K. R. Mackenzie, and Emilio Segre. Their astatine was made by bombarding bismuth with alpha particles. Astatine is the rarest among all naturally occurring elements. Only 30 grams of astatine is predicted to be present at any given time in the entirety of Earth's crust. Small amounts of astatine exist in nature as a result of decay of uranium and thorium. So although the total amount of astatine in the Earth's crust at any particular time is less than 30 grams, due to its scarcity, astatine is produced when it is needed. A total of 0.5 micrograms of astatine has been produced to date. Astatine is a highly radioactive element and it is known as the heaviest halogen. Its chemical properties are believed to be similar to those of iodine. It has been little researched because all its isotopes have short lives. A mass spectrometer has been used to confirm that astatine behaves chemically like other halogens, particularly iodine. Physical properties of astatine. Astatine is a very radioactive substance which is the rarest among all the naturally occurring elements. The atomic mass of astatine is 210. The melting point of astatine is at 302 degrees Celsius. The estimated boiling point of astatine is at 337 degrees Celsius. The density of astatine is still unknown. Most of the physical properties of astatine has been derived using theoretical methods. Astatine is very sublime. Half of the astatine will vaporize in an hour if it's exposed to room temperature. The structure of astatine is unknown. It is predicted to have some structure as iodine. There are 39 known isotopes of astatine. As of yet, and theoretical modeling suggests that there could be 37 more isotopes. Most of the properties of astatine are still not known, like its color. It is believed that astatine is dark, close to black in appearance, based on the other halogen family member color patterns. Chemical properties of astatine. The chemical properties of astatine have only been studied using tracer experiments. Astatine is the least reactive among all halogens. The anion formation property of astatine is similar to that of other halogen. The astatine compounds displaying an oxidation state of +1 are similar in properties to silver compounds displaying the same oxidation state. The organic chemistry of properties of astatine are akin to iodine. Hazards of astatine. Astatine does not pose any threat to environment as it does not occur in significant amounts. Astatine can be obtained in variety of ways, but not in weighable amounts. Astatine 211 is made in nuclear reactors by the neutron bombardment of bismuth 200. Uses of astatine. Astatine is known to accumulate in the thyroid and occasionally is preferred treatment for hyperthyroidism and thyroid cancer because the particles emitted from astatine provide more energy than radiolabeled iodine, the other treatment method. However, astatine has shown a tendency to induce tumors, so it is use limited. There is no currently uses for astatine outside of research. The half-life of the most stable isotope is only 8 hours, and the only tiny amounts had been ever produced. Astatine has no known biological role. It is toxic due to its radioactivity.